Please join me in welcoming Ankit to the stage.
Can you hear me well? Is the mic working? Okay, yeah, awesome. So thanks for sticking around. I'm a bit surprised that we still have some people at 5 o'clock. So I'll keep it short and try and keep it interesting for those who are here. So this is the quick agenda. Like Wayfair is a big answer first company, so let's get through what you're going to get through if you stick around for 20 minutes. I'll quickly go over what Wayfair does, what constitutes computer vision at Wayfair, what are the different teams that work together to make it all happen, and then the focus will be what are the different deep learning models we use in Wayfair, and why do we need that many of them? And finally, the biggest focus is going to be how we are leveraging this cutting edge technology to generate revenue and have cost-saving applications, because that's where it matters. This is a business track. This is all R&D if you don't generate money out of it. So that's what the focus is going to be. So let's start with Wayfair. So Wayfair, how many of you have shopped for furniture online? Oh, nice, awesome. So thank you for shopping at Wayfair. So as you know, Wayfair is an online company that happens to that sells furniture. And the way our co-founder puts it is that we are a tech company that happens to sell furniture. So we have a massive focus on technology. How do we build our tech stack? How do we build our infrastructure? How do we build our cutting edge technology or innovation so that we can support our customers better? And our vision is everyone should live in the home that they love. So with that, there's a bit of a difference when you shop for home versus when you shop for a utility item. So if you're shopping for a battery or say Bounty paper rolls, you have a different mindset. You want to come to a site, you want to see the product, add to cart, buy it, and move on, right? Whereas when you're shopping for your home, there's a bit of uniqueness you look for. You have a different style in mind. You don't always look for, all right, this is the most popular table lamp, I'm going to buy it, and I'm going to move out. You look for that uniqueness, and that's where Wayfair is trying to focus on technology, on how do we provide that to our customers. Now, Wayfair is one of the biggest players in the market. There are not many markets, actually. If you look at this particular field of online furniture selling, it's a fragmented market. There are big retail players like IKEA, Ashley Furniture, but in the online space, everybody's just trying to get into it. And we are growing at a very fast pace. So in the last 12 months, this data is a little outdated, but we had around $6 billion of revenue that we generated in the last year. So we're growing at a very fast pace. And right now, our presence is mainly in US and in Canada, but we are increasing our footprint in UK, Berlin, and we are expanding from there. And this is going to get even bigger, because if you think of the furniture market, right now it's at around $300 billion a year, and in the next 8 to 10 years, it's going to be around $400 billion. And the market is going to shift more and more towards online, because if you think of our demographic, right now, a lot of millennials who are between the age of 18 and 35, in the next 8 to 10 years, they'll be at a life stage when they're buying their first home, when they're trying to furnish their home. And they are plugged into Wayfair, and they're plugged into how to buy furniture online. And that's where Wayfair will have massive advantage. So now let's jump into what constitutes computer vision at Wayfair and how does it work. So how many of you have seen this, or how many of you know what Captain Planet is? All right, I learned about this 2 weeks back, so I didn't know about Captain Planet. So I saw this on one of the slides on the product manager, and I was like, okay, I'm going to steal it. But this is how Wayfair works. So basically, we are in an STO organization. We are a 12,000 people company, but we don't want to lose the sight of how do we work as an entrepreneur or a startup. So we have these single-threaded ownerships or teams where engineering, design, product managers, data scientists, and web analytics all come together to make it happen. And that's where the Captain Planet of computer vision comes out. So how does computer vision work? In a very simplistic way, and I'm not going to go into the technical details of the different algorithms, that's a technical track, but at a very high level, when we find an image or when a customer uploads an image, we identify the different visual phrases in that particular image, right? So when you look at that image of a Pikachu, you see there's a pointy ear, then you have eyes, then you have nose, and then you can identify different colors. So these are called visual phrases. Then the algorithm hits our massive data sets of millions and millions of images to identify the other images that have very similar visual phrases. And then at the end of it, sort ranks all of the images based on visual similarity. So that's a very high-level overview of how computer vision works. From a technical standpoint, however, the fundamental problem that we are trying to solve is how do we convert an image in a representation that can be searched. So traditional way people search is they go to a site and they type in red sofa chair with a high back. That's the normal way of searching. We want to change it because, again, supporting that uniqueness. If you are walking around in a crate and barrel and you really like a particular office chair, it's like $3,000. You don't want to buy a $3,000 chair. Take a picture and upload it to our site. But that's where we have to convert that image in a representation that can be searched. How do we solve it? Sorry for the small font. How do we solve it is through deep convolutional neural networks. And that's where our data scientists come in. They are the ones who are building these massive deep learning, machine learning algorithms that are supporting our computer vision department. How does it work? Let's not go into that. But what I do want to focus on is how do we train our models? That's going to be key because it's different when you do hot dog versus not hot dog. How many people got that reference? There you go, a couple of them. So as you watch Silicon Valley, you'll see that. Or when you're doing cat images, that's still fine. But when you do furniture, it's a different ball game because the way we train our models is we get many images for a particular product from our suppliers. So if you think of that red chair, we get a front shot, we get a side shot, and then we get a top shot. So we provide those images to our model and make it learn that these are all images of the same SKU. And then we provide them other images that are visually very dissimilar. So for us, it's very easy to understand why those two images are different. But the model has to learn what is different about those two. The color is different. The shape is different. The size is different. The texture of the material is different. So all of that the model has to learn. And for that, there needs to be a lot and lot of training. And that's where having this image database is going to be massively important. But again, talking about one chair versus millions of SKUs, there's a different ball game. So we have 12 plus million SKUs. For each SKU, we have 7 plus images. So we're talking about 100 million images and hundreds of classes. So it's not just about accent chairs. We also train our models on accent pillows, on beds, on office desks, on conference tables. So it's a very, very different ball game, and that needs a lot of scaling and a lot of infrastructure support. So that's where there are 4 milestones to our model building. First one is training data curation. That's probably the most painful and time-consuming step that we have in the model building, because we have a massive offshore team where somebody, a human, is sitting and tagging an image, 2 images, as these two are similar, and they're different from the third one. So that needs a lot of investment, but that's what you have to do if you're trying to build an AI model, because we are trying to replicate what a human would see, right? The second step is model training, and this is probably the only slide that is text heavy, so don't worry about too much boring stuff. There are 2 different types of model that we have to train. If we are trying to identify SKUs that are visually very similar, then we have visual search models where we are doing product-based training. Whereas we have models, and you'll see that in the next few slides, that helps you curate rooms and style. For that, we are leveraging some of our information from interior designers. So we have designers on our team who will come and say that this room has modern styling, has a lot of furniture that looks like conference room. So from that curation, we are building room and style-based models. Third step is to support this massive scale of millions of SKUs, real-time deployment, microsecond response rate. We have to have massive infrastructure. And that's where we are leveraging our in-house platforms and some vendor-provided platforms. And while we are using vendor-provided platforms, one of our key tasks is that, okay, how do we reverse engineer? How do we learn from that, and how do we build that in-house? And finally, the product integration. That's where I'm going to focus on. Since I'm on the web analytics team, my responsibility is to figure out the business applications of these AI algorithms. So in product integrations, we have 4 things. One is product partnerships. So how do we partner with different parts of Wayfair.com to figure out different applications? Search with photo. And then third one is internal integrations. So through internal integrations, basically we are trying to find optimization opportunities. How can we replace humans? How can we cut down costs? So that's what the product integration is all about. So now let's get into what are the different types of deep learning models we have and why do we need them. So we have 5 types of deep learning models right now at Wayfair, and this is work in progress. Every day data scientists are building more and more models. And fun fact, actually the whole computer vision department started as a side project. One of our data scientists spent a Friday afternoon building an image recognition algorithm, and then he was like, cool, I got something. We may have some business applications. And from that onwards, we hired 3 people that turned into a department that is right now 60 people. So that's how the products are being built at Wayfair. We try things, and then we make something happen. So we have 5 models: visual search similarity, object detection, silo versus environmental, room detection, and style detection. And I'm going to go over these very briefly. But why do we need 5 models? So quick question for the audience here is that when you see that image on the right, what do you see in that image? OK. You had a question? Yeah, what? OK. That's what I want. Like, what do you see in that image? Furniture. Great. What kind of furniture? Dining room. White. Living room. There you go, fireplace. So basically, you identified what kind of a room it is. You identified it has furniture in it, and you identified the color of the furniture is white. What additionally we are looking at when we see this image is what kind of furniture it is. Is it modern? Is it eclectic? Is it coastal? So we, as humans, what we can process in microseconds, we have to train a model to learn that. And that's why we need all these models. So first thing, as you called out, there's a dining table in this room. There's lighting. There's wall art. There's a sofa. There are pillows. So we have to identify all those items in that room. So if a customer has uploaded this image, it's our responsibility to identify every one of those items in that room. And that's why we have an object detection model. Is it a silo image or an environmental image? Does it have multiple items in it? Does it have a background? Or is it just a plain background? What kind of a room it is? Is it a living room, dining room, kitchen? So this looks like a combination of living room and dining room, because you can see a dining table along with the living room furniture. And what kind of a style it is. That's why when you, again, I'll draw the same remark, is that when you see these algorithms being used for cat images or for hot dogs, that's a different game, because here we have to think of what all customers can think of, and we have to anticipate, and we have to build algorithms around it. So visual search similarity. So this is an algorithm that is more focused towards revenue generation. When a customer uploads that kind of a floor lamp with 3 legs and a circular peripheral, then in microseconds, we should be able to identify what other lamps we have in stock that the customer might be interested in. And that's where visual similarity algorithm kicks in. The object detection is, we can't expect our customers to find an image with a white background. So we have to have functionality where a customer can upload this image and then say that I'm not interested in that orange chair, I'm more interested in that office chair. So that's where the object detection model works very well. Silo environmental is the same concept, that where we need more object detection algorithms. And then we have to have room detection. And you'll see in the next slide why we need all those and how does it all come together. And then we need style. So style is a very subjective thing. Like if you think of style, like what are the different styles come to your mind? Like there are 4 there, but anything else that comes to your mind? There you go, classic. Those are the only 2 I knew when I joined this industry, modern and traditional. But I came to know that there are a lot more nuances to it. There's cottage, there's industrial, there you go. and we have glam, minimalist, eclectic. So there are so many different styles that we have to be practical, and we had to limit it to top 9 styles through which we can train our models. So right now we are operating in a model with 9 different style detections, and as we are gaining more and more revenue and we are gaining more and more investment, we're expanding our toolkit. How does it all come together? So our vision is, imagine if a customer uploads this kind of an image. Step 1, we have to identify it's a living room. Step 2, we have to identify it's a modern living room. Step 3 is that we have to identify what all is in that room. So we can see there's a sofa in there, there are a couple of chairs, there's a coffee table already there, and there's a lighting fixture there as well. What's missing? On the wall, there's nothing else. And that's what we need to anticipate for our customers, that they have uploaded an image of a room that is living room, modern, has everything but a wall art. And that's where we can make recommendations. That's where the personalization and recommendation kicks in, where we can see that the overall theme is light, modern, and of a living room. So of all the SKUs that we have, this is the kind of wall art that the customer might like. And that's what we recommend. And that's why we have higher conversion rates. So now let's talk about 3 different work streams in computer vision. How do we make money out of it, right? How do we save money out of this whole application? So first one is search with photo. So here's an example. Yeah. So this is our home page. You can click on that camera photo, and you see this kind of a modal that pops up. In that, you can select one of our images. This is all happening in real time. So this is what you can test on the site. You can see that kind of a brown chair or that wall art, and immediately there are recommendations that are popping out with the pricing, with the reviews that you can buy and have it shipped to your home. Other option is that you can actually upload an image. And this is where the example of crate and barrel kicks in. If you're in a really expensive store, you can just take a picture, upload on our site, and let's wait for the uploading. But when you upload this kind of an image, suddenly the model picks up that the image that you have uploaded has multiple furnitures. And you can select, I'm looking for that red chair or that kind of a wall art in that crate and barrel store, and that's what I want to buy. So that's how we are trying to increase our share of wallet, because people have limited amount of money that they can spend. So how can we compete better through our brick and mortar stores? So product partnerships. Now product partnerships is a great way of generating revenue and solving customer problems. You'll see that a lot, that we are passionate about solving customer problems, but here's an example of how we are doing that. So in the previous couple of presentations, people talked about out of stock. That's a massive problem for Wayfair or any retail company. We have an out of stock rate which is upward of 5% or more. So it is significant enough problem where a customer likes something, wants to buy it, but it's out of stock. So we have to solve it. And one way to solve it is that give them an option to come back. But by that time, they have lost the intent and we have lost the sale. The second integration or the partnership is the Chrome extension, which I'm really pumped about. So let's talk about the out of stock. So this is a typical product page. You can see a customer landed on this page, really liked this orange chair, but it's out of stock. Now, if you think of furniture, people are not that brand centric at this point, at least. They don't care for a particular supplier. So imagine if we have an algorithm that can run in real time and identify what are the other SKUs out of 12 million that are visually very similar to an accuracy of 95 to 96% of matching rate, identify SKUs that are visually very, very similar to that particular chair, have reviews, have ratings, have pricing that is very similar to the original seed SKU. Now we are not losing that sale. Now the customer has an option of buying the other yellow, green, or white chair from different suppliers. So instead of somebody manually going through millions of SKUs, we have an algorithm that is doing that in real time and making sale for us. And with that, now customers are not exiting at the higher rate, because previously the only option the customer had was, let me go back and search for something else, or let me exit this site. So we have lower exit rates. We have lower notify me rate. And the reason why we don't want too many people to click on notify me is, again, the item comes back in 3 to 5 days. And by that time, the customer has moved on, or worse, they have bought from some other competitor. And this improves our session conversion as well. Now, the Chrome extension is a very interesting application that I was very surprised by. And this is, again, how Wayfair thinks of innovation. So we have a massive, not a massive, actually, a pretty big B2B portfolio. We have around 1.2 million customers, of which 30% are interior designers. So these are customers who are designing their clients' home by shopping at Wayfair or West Elm or Crate and Barrel. So what we did is that we built a tool powered by our computer vision algorithms where they can go to West Elm, like this chair, and the moment they click on our Chrome extension, out comes that drawer. And now all that image is captured for them to import into Wayfair's platform. So now we know what customers are shopping for, what our customers are shopping for in West Elm. And not only that, in real time, we're also recommending discover similar Wayfair options. So if an interior designer is not hell-bent on buying from West Elm, we are trying to drive that revenue towards Wayfair. So that's how we are trying to, again, increase our share of wallet and cut down on our competitors. The third one is the internal integrations. So this is a cost-saving platform. This was a very interesting case. So basically in EU, the regulations are a lot more about copyrighted items. So we had some sort of a lawsuit in 2017, and we thought that, okay, hey, how do we solve that problem? Right now, we have millions of SKUs, and some suppliers have filed lawsuit on saying that I'm selling this $5,000 chair, and another supplier from some other country is selling a visually very similar chair for $300. I don't want to sell on Wayfair anymore. So the way we can solve it is that somebody can look through all the images and click and point and that this is an original version and this is a knockoff version. That's not practical. There are 12 million SKUs that we operate at. And that's where the knockoff validation tool came into the play. It's again powered by our image recognition algorithm, where it can automatically identify that which chair is $5,000 chair and which one is very similar but only costs $300. This also brings transparency to our customers, because now we can work with the suppliers to populate the product description so that the customers know why this chair is $5,000 and why this chair is $300. So that's how we are saving on legal costs, we are saving on manual costs, and basically we are having a much better supplier relationship because we work with thousands of suppliers. So we have to be customer focused, but suppliers are also part of the family. And the last internal integration, I think this is my last slide, so we're running out of time, is image tagging tool. So if you go to Wayfair.com, we have something called Shop the Look. So if you are just looking for inspirations, you can go to our site, and there are hundreds and thousands of images where we have curated rooms for you with images, with items tagged in it. So if you take an image of this room, there'll be many black conference chairs tagged, and then these tables will be tagged as well. So that you can just click on that and you can buy it. At this point, all of this was done manually, where somebody was looking at that image and saying that there are 5 items in this. Let me tag these images. Let me find those images and then populate that. We built a tool around it. And then we saved on all of those offshore costs. So now we have a tool powered by our 96% accurate visual similar algorithm, which is doing all that tagging for us automatically. So that's how we are using some of these innovative AI technologies to either generate revenue or save on costs. So we have 6 minutes, so in 24 minutes, what we covered, a little bit about Wayfair, what are the different models we have in Wayfair that are deep learning models, and how are we using them? Questions? Yep.
You mentioned a limit of 500 dimensions for your NVIDIA space. Is that just to keep it feasible?
It's more around practicality. So we are buying more and more GPUs at this point, so it's a pretty expensive resource. But we are starting with, let's start with 500. Again, all these, one part of my responsibility is calculate how much value we are getting out of these projects. So as we built out knockoff tool, we saved like $6 million or more per year on that. That covers cost of some GPUs. So okay, now we have one tool that provides us, let's increase 500 to 1,000. So every time we are thinking of these innovative applications, we are funding it more and more to get more and more infrastructure.
Thank you.
Yep.
For your Chrome extension, we find that there are certain types of images that have a higher likelihood of not matching something, or customers are not clicking on also available by Wayfair. And what do you do to then think about feature engineering that's missing so that you can make the recommendation better?
Mm-hmm. Great question. So one of the things that is sort of hampering our performance at this point is how much are we training our models. So the way we operate is that we have 750 plus different classes. So we have accent chair as a class, a sofa as a class, office chair as a class. So we have 750 classes of furniture that we sell. Now we can't start from day one saying that, okay, we're going to train the model on everything. So to answer your question, the images for which we don't get results are often for which we don't have embeddings, where we don't have model trained. So for example, we never trained the models on accent pillows because we never saw that we'd get too much revenue out of them, and our customers are not looking for them. So we deprioritize that. So that's one of the reasons why somebody will look for an accent pillow on West Elm, but they will not find any recommendations, or they won't be able to capture the image of that. Does that answer your question?
Kind of, yeah.
Okay. Any other questions? Yep.
Are you measuring the conversion rates from these tools with these enhancements?
Yep, absolutely. That's critical. Again, when we develop these, we have to justify why we need another $1 million or $2 million or $10 million. And the way we do that is through A/B testing. So the carousel that you saw in one of those, this one, so if you see this carousel, it says try these instead. Previously, there was a carousel that said customers also viewed, and that was not limited to these chairs. That was the customers who viewed this chair also viewed XYZ, which was a typical collaborative filtering algorithm. So we put them against each other through an A/B test and see how much conversion rate lift we are getting by putting these kind of algorithms.
And are you able to share numbers around it?
I won't be able to share the number, but it's sizable, it's statistically significant for us to actually roll this out. It's in lower, less than 5%, but it's significant. Any more questions? Yeah?
Do you provide any way for consumers to give you feedback like, oh, this model gave me what, I mean, like this image search gave me what I wanted, or this image search was complete crap?
So right now, there's no proper mechanism where a customer can give us that specific feedback. There are a couple of ways we are measuring that. One is when a customer does not click on an image, that's our interpretation of we may not have given them the best recommendation. It could be because we found the visually similar item, but the item sucked, was really expensive, or had no ratings. That's one interpretation. The other interpretation is the visual similarity was not there. And that's where we do some sort of a postmortem on non-clicks through our user testing. So we don't have direct mechanism where a customer can say what worked, what didn't work. Because again, as we have more and more surveys, we are seeing that our customers are not really open to it. They just want to go and buy stuff. They don't want to give too much feedback. So it slows down the site as well. So from a performance standpoint, we don't add too many surveys.
Thank you.
All right. Thanks for
Okay,
your
well,
time.
thank you so much.
Yeah.